Good afternoon to everyone. I am Aruna Arichami, Assistant Professor, Department of Information Technology, SNS College of Technology. Today, my students of second year AMLB section, they are going to discuss about the case study of serializability. So that could be discussed by Yugesh, Sonali, Manasa, Miduna Lakshmi and Sivashankari. You can start.
Good morning all. I am Yukesh. Today we are going to discuss a topic about serializability in online banking. So serializability in online banking are about our day-to-day life transactioning amounts from bank, and some of the customers have essentially drawbacks in online bank checking and balance checking. So serializability is very essential to maintain the database in the online banking system.
Yes, in real world entity, definitely we are having this type of a back thing, because we are going for a concurrent execution. Intermediately, we are having any server failure, any other issues, your data will be an inconsistency. So that only we are going to discuss.
Okay, I would like to share about the concept of serializability. If the transaction had been executed one after the another, so the outcome of the transaction must be same. There are two major types of serializability: view serializability and conflict serializability. In conflict serializability, conflicting operations can be preserve order and the non-conflicting operations can be reordered. So the precedence graph can be used to check for this, and in view serializability, it considers the final value and it reads from the relationships. It is harder to implement and verify. So if the schedule is not serializable, the following issues might happen: lost update, dirty read, uncommitted data being read by others.
Yes, very good. If you are using a serializability concept, definitely we have to remove these type of anomalies in the real world entity.
So hello all, I am going to discuss about some examples regarding to the serializability and non-serializability. Serializability, consider an example of transferring amount like 500 from account A to account B. For example, first we need to read the balance of the account A, read A, we use that kind of keyword, and then we will subtract the 500 from the account A's balance, and then we will write A. We will update the balance in the account A's account. Then we will add that 500 into the B's account, then we will read B, then we will write B. This is the serializability. In the case of non-serializability, there will be a task called where the T2 reads before the TA writes. So there will be an incurrent balance updation will be occurs. And to check this, we have the two types, which is if there is no cycle formed, that is the non-conflict serializability, and if a cycle is formed, that is the conflict serializability.
Yes, very good, Mithuna. So due to that, we can able to eliminate the conflict as well as the view serializability by following this non-serial. So just we are going to equivalent the non-serial schedule to the equivalent serial schedule.
I would like to share the solution. To solve this, we can apply concurrency control protocol. So the first method is two-phase locking, and here the operations are data locking resources while we are using it in the growing phase, and after data are released in the syncing phase, and preventing concurrency access. For example, if T1 cannot read it until T1 finishes writing. And the second method is time-step ordering, and here each transaction gives the time step. Older transaction gives more priority, so the younger transaction get waits to complete the older transaction, and we using these two methods, the serializability for ordering the solutions, so it doesn't make any affect the result.
Yes, very good. So by using a two-phase locking protocol, we can able to give the shared lock and exclusive lock for that particular transaction in the schedule. Due to that, we can able to overcome this particular problem.
So I am here to tell about the summary and the key takeaways. So the 2PL guarantees conflict serializability, but it can cause deadlock, whereas timestamp ordering can avoid deadlock, but it may increase the transaction abortion rate. And key takeaways: so serializability ensures data consistency in the concurrent environment, and conflict serializability is easier to implement, but it can be verified using precedence graph. And concurrency controlling mechanisms like 2PL and timestamp ordering are the practical solution for this serializability. And I would like to conclude that serializability can be enforced in banking system, where even minor anomalies can lead to greater loss and also legal issues.
Thank you students for joining this group discussion to discuss about the real world issue in the day-to-day life. Thank you.
Thank you.
Thank you.